Hello, everyone. My name is Julia Cantillon. I am a PhD candidate in the Dalhousie Coastal Hydrology Lab in the Center for Water Resources in the Department of Civil and Resource Engineering at Dalhousie University. I'm very excited to have the opportunity to talk in this session today about hands-on hydrology. My talk today is taking a slightly more hands-off approach to hydrology using wireless monitoring for hydrologic applications. So in my talk today, I'm going to discuss two methods that I have applied to use wireless monitoring to monitor Sable Island's freshwater resources, and I will provide you with the resources that you need so you could get started and apply wireless sensor monitoring to a hydrologic application that is of interest to you. Before I begin, I wanted to take a brief moment to thank the CYHS for hosting this session and for inviting me to talk today. And before I begin my talk, I just want to take a very quick moment to acknowledge the funding that I received to make this work possible and all the support that I received in this work. First, I want to thank Dr. Barrett Kurlick and the support he provided me, including financial support from his Neopart Early Career and Knowledge Mobilization grants. And I also want to thank all of the lab members who contributed in the field, many of which are actually presenting or attending this session today. I also want to thank Dr. Scott Ketchison from Athabasca University, who sort of got me started on wireless monitoring and who is much better and more competent in wireless monitoring system networks than I am. Finally, I want to acknowledge that the low-cost sensor that I will be talking about in the later portion of my talk today was developed by John Drage, who is a senior hydrogeologist with the government of Nova Scotia in the Geoscience and Mines Department, and he helped me significantly in the development of my own sensor that I've applied and will be talking to you about. So to begin, I just wanted to really briefly introduce you to what a wireless sensor network is and why it could be so valuable to your research. Traditionally, a lot of hydrologic monitoring is achieved using a very small number of very expensive and very high precision sensors. But the challenge with these sensors is that they require you to go to the sensor and physically retrieve the sensor in order to collect the data. In order to collect this data, you have to go to the equipment at the end of the experiment or at the end of the deployment period and recover the unit in order to recover the data. However, technological advancements and an increasing demand for more wireless and real-time data has motivated the development of these wireless sensor networks, which allow us to use very low-power devices that have a sensor, a processor, some sort of storage capability, and a power supply, but most importantly, they have a transceiver. This transceiver is what enables us to actually combine and connect these digital data loggers that we've traditionally used for hydrologic applications with long-range communication networks such as satellites or the internet. And using these things combined, we now have sensors that are able to measure hydrologic phenomenon and transmit the data in near real time. So these devices are incredibly useful for getting data from a variety of different sites and for tons of different research questions. They're very valuable for remote sites, such as island sites, such as one I work on, as pictured here. But they're also valuable for northern sites or more remote sites. Additionally, these devices allow you to get real-time data and will alert you to environmental conditions and changes in hydrologic conditions in near real time. This is critical as it will allow us to better understand hydrologic phenomena and what may be driving some of the changes we are observing. Finally, there is a large push to make these wireless sensor networks low cost, and this makes them highly valuable for community-based sensor networks such as the one John Drage set up for the province of Nova Scotia and the shallow aquifer monitoring. So today I will be talking to you about how I have developed wireless sensor networks using two different technologies to monitor in real time atmospheric conditions such as temperature and relative humidity, but more so to monitor water levels and water quality in surface water ponds, as well as to monitor groundwater conditions. And the most important part about these systems is that I am able to effortlessly share this data with managers, local stakeholders, and with you today through a near continuously updated real-time website, publicly accessible website. So I've done this using two different technologies, which I'm just going to talk to you very briefly about. The first is just a Campbell Scientific and Riot technology system that uses satellite and the GO satellite system to collect this data and transmit it in real time. The second is a much more low cost system that uses particle devices and the Internet of Things to be able to monitor water hydrologic phenomenon and transmit that data via Wi-Fi systems that are oftentimes in place. So just talking about the system I've set up on Sable Island, we have a website that you can actually access at dal.ca/site/hydro, and using the Sable Island tab, you can read a bit more about why wireless monitoring for Sable Island is so important and why the site is so well suited to it, and some of the water challenges that the island is facing. But you can also learn a little bit more about some of the wireless sensor network things that we are applying, such as wave buoys, and you can access the data there. But more so this wireless pond monitoring that I'm doing using the GO satellite system and this Riot technology, and how you can access the data via our dashboard link. And secondly, we also have this wireless aquifer monitoring, which unfortunately isn't active right now, but will be in the coming months, and how we develop this in combination with the Nova Scotia Geological Survey. So that's just a bit about that. So moving into this wireless network system that I developed and applied on Sable Island using the Riot technology and Campbell Scientific technology. This network is incredibly complex, and despite being a wireless sensor network, it has got a boatload of wires that had to be installed in the field, and it was quite rigorous to develop the code to install, and there was a very high barrier to entry to learning to apply this technology, not only from the cost of the system, but because of some of the technology that is involved in it. So what this system does in its essence is every 30 minutes, a Campbell Scientific data logger turns on, and it initiates communications with a sensor that is wired directly into it, and it makes a measurement of air temperature and relative humidity, but it also turns on this gateway. This gateway communicates with these moats. These moats are installed around the ponds on Sable Island and are wired directly to these sensors using meters and meters of wire. And these wires are installed and in stilling wells in the ponds. Using these stilling wells, we're able to make a measurement of water level, which tells us about how the volume of water that is available in these surface water ponds, which is important for the ecosystem. It also makes a measure of temperature, which is important for things like algal blooms, but it also makes measurements of electrical conductivity, which in an island environment is very important as it's an indicator of water quality and potential breaching incidents that occur on this island. So once the gateway has turned on the moat, which turns on the sensor, and the sensor makes its little measurement, the measurement and the data is sent back to the moat and back to the gateway. And this happens simultaneously in all three of our moats in 3 different ponds on Sable Island. The data goes back to this gateway, and the gateway and these sensors send all of the data back to our data logger, where a GO satellite transmitter then uses a specialized Yagi antenna to send the data out to the GO satellite system. The GO satellite system stores this data for a few hours, and in order to get that data back down, we had to develop a website using the Campbell Scientific Cloud, which we got a lot of technical support for, because that system is quite complex. But this Campbell Cloud website that we've developed is able to ingest this data and post it and make it publicly available on a website. So just what some of this data looks like is just a small screenshot here, so you can see this is some of the earliest data that we collected, where you're able to see we're able to monitor this pond water level in the 3 different ponds in real time, where we get all these data points every 30 minutes. We're able to monitor the pond temperatures and the electrical conductivity. And all of this data is available on our website here, Sable Research. And if you read about it, you'll find a link to access it. Unfortunately, our system is down right now, but if you check back in about a month, you should be able to access that information and see some of the data that we are collecting. So this system is incredibly well suited to Sable Island, and it functioned quite well for a period of time before we had some technical difficulties. However, it is quite expensive. This system costed in excess of $30,000, and we were incredibly lucky that it was so well suited to Sable Island and we were able to get funding to support this. However, a lot of the hydrologic questions that many of us are trying to answer are smaller scale and might not have the same funding support. So in order to address some of these hydrologic questions, we need a cost-efficient alternative. And that is what John Drage from these Nova Scotia, the hydrogeologist from Nova Scotia did. So I'm going to talk to you about this cost-efficient method and alternative that he developed that is using the Internet of Things, which connects to widely available Wi-Fi networks or cellular networks and can help us as hydrologists overcome these high-cost barriers to collecting and transmitting and getting this real-time groundwater or surface water monitoring data. So the system that we use is a very low-cost, do-it-yourself system, and John Drage established this as part of a community science groundwater level monitoring network for Nova Scotia. And recently, with support from him and following the extensive and very thorough instructions he provided, I was able to develop this system and deploy one of these loggers for less than $300 on Sable Island. So I'm going to take you through some of the large-scale steps that you need to understand in order to be able to do so yourself and develop this sort of sensor to investigate your own hydrologic questions. So unfortunately, it is quite challenging for me to take you through the physical construction process on how to build one of these and how to code the photon chip that is inside of them, especially in a virtual setting. And within the time constraints of my presentation today. So for the purpose of my talk today, I'm just going to very briefly take you through some of the broad steps and the utility of these systems. And as I mentioned, the detailed construction, and coding data that you will need in order to build one yourself is available through a website, as I showed on my slide, which is just highlighted here from John Drage, and it shows you the step-by-step on how the parts you will need and how to construct the meter. And then later, the part I'm going to focus on is how you set up the software in order to be able to get the data from your photon chip to the internet so you can actually access and view it. So as I mentioned, I am not going to take you through as much of the physical construction, but I just want to highlight a few things. Many of the parts that you need for these devices can be purchased from a hardware store, purchased from Amazon, but the main thing you need is a very handy photon chip, and although it looks intimidating, it is incredibly user-friendly, well documented online, and it is very easy to wire, understand, and connect to. The other thing you need is an ultrasonic sensor, which is just, again, readily available and purchased online, which just will measure the depth to the water surface. So this unfortunately only measures the water level, but using some simple offsets in the code I will present, you're able to, you can adjust the sensor to be able to make measurements to a water level in either a groundwater or surface water application or any sort of thing you're interested in. So now into the interesting thing. How do you set up the software to be able to get this data in real time? So the first thing, once you open your box for your particle chip, you just actually access the particle app as shown here. And it takes you through a very, very, very simple 3-step process to set up this chip. You just have to plug your chip in to a power source and connect the Wi-Fi of the chip. And then once you connect and claim your chip, you connect and put the chip onto your Wi-Fi network where your sensor will be located. So it is important that your field site has a Wi-Fi or a cellular data connection. But once you have that, which many less remote sites do, you will be able to use this chip to make measurements and send data to the internet. So in order to actually access this data, you need to create a ThingSpeak account. So let me just show you how to do that. So I'm just demonstrating my ThingSpeak account right now, where you can clearly see once you make an account, you can set up some channels, and I have a channel for my well on Sable Island, and you can make it public or private, and you can adjust all the settings for the channel, where you have to create a label for it, description for it, and you fill out the field that your sensor is going to be measuring. So using these ultrasonic sensors, we are making a level measurement, so that is what we were going to be doing. There's all sorts of other information you can fill out, but for the purposes of my channel, I haven't done that. You also have a public view of the data that you can see as we're collecting it. So here you can see some of the data we've collected and some of the large gaps we have from Wi-Fi interruptions on Sable Island. But the most important thing you will need to access once you set up your ThingSpeak account is just your API keys, where you can access your channel ID and create these keys to actually broadcast your data. So once you set up your ThingSpeak account, you get this access to this webhook. This webhook is what you are going to then put into your particle account that you made on this app. And when you log into the particle account online, you just simply paste in the code that John so thoroughly outlined. As you can see here, it's a very well documented code, and it is quite straightforward. So you just have to modify 3 simple things in it. At one point, you have to enter in some values for the hang down or the set up of your instrument, so we can make accurate measurements of water level relative to some data. You can also change how frequently the sensor makes a reading, and finally you just have to connect it to your ThingSpeak account. So if here in this line here, you're able to connect the sensor to your ThingSpeak account. And then once you do that, you just are able to compile and verify your code. And when your photon chip is connected to your Wi-Fi service, as we did in the first step, you can then just flash the code over to your chip. And unfortunately, my chip is not connected right now. But once you do that, you are actually logging data at the interval you specified in that code. So it is a very, very straightforward process. And then you just install your sensor on either a well or above a body of water, and you can actually see the data coming in real time as we have here. So John Drage with the province has also done so, and I just wanted to highlight very briefly the work he has done and the extensive monitoring that he has created for the province of Nova Scotia on this website, where each of these red dots is a well that is monitoring water level on someone's property. There is soon to be a dot on Sable Island for this development. So with that, I just want to conclude my presentation and take a brief moment to thank you all for your attention today. I also look forward to taking questions in the discussion period to follow in the session. And I also want to thank all of those who made this opportunity available. Finally, I wanted to provide you a nice summary location with all of the links that you will need to get started to develop this. I look forward to talking about these hydrologic applications of these wireless sensor networks and how you might be interested in using it in your work. Thank you.